Leetcode question 622. Design circular queue. Design your implementation of the circular queue. The circular queue is a linear data structure in which the operations are performed based on first in, first out principle, and then the last position is connected back to the first position to make a circle. It's also called ring buffer. One of the benefits of the circular queue is that we can make use of the spaces in front of the queue. In a normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in the front of the queue. But using circular queue, we can use the space to store new values. So implement my circular queue class. Initialize object with size of the queue to be k. Get front item from the queue. If the queue is empty, return -1. Get the last element from the queue. And then in queue, insert an element into the circular queue. Return true if the operation is successful. Dequeue, delete an element from the circular queue. Is empty, check whether the circular queue is empty or not. Is full, check whether it's full or not. You must solve the problem without using the built-in queue data structure in your programming language. Let's take a look at example 1. So we first initialize a queue with size k equals 3. In Q1, so put 1 in it. In Q2, put 2 in it. In Q3, put 3 in it. And then called in Q4, the return value is false because you already have 3 elements in the queue. So you cannot put any more elements into the queue. So that's why the return value is false. The rare elements, the last element is element 3, is full, return true. And then dequeue, return true because we can pop the elements from the queue. And then in Q4, now after we already remove one element, so there's a space left in the queue that we can insert a new element for. Return true. Rare, in this case, the last element is 4. So the idea for solving this one is to use linked list, specifically doubly linked list. So basically the 2 pointers, we have the 2 pointers. One is left pointer. So when we call dequeue, we actually delete the node after left pointer. So that in that case, we always pop from the front of the queue. The left pointer points to the elements that's first inserted into the queue. And the right pointer indicates the end of the linked list. When we call in queue, we insert a node before the right pointer. So basically, to design this, the data structure we are using is doubly linked list, with the left pointer, right pointer denotes the start and the end of this linked list. So I already specified a node class with value and the previous node and next node. So now let's implement this circular queue. Self.k is k. So that is the capacity. So let's set the capacity and then also the count. And then set the self.left is just this node. And then self.right is also this node. So initially self.left.next is just self.right. And then self.right previous is just self.left. When we insert an element using enqueue, we insert a node before the right pointer. So in that case, the next is just self.. So the previous is just self.right.previous. And then we will insert. So in this case, we create a node. Node is node actually value. And then for this node, the left node is the previous node is self.right.previous. And then the next node is self.right. So this is our node. And then we also need to point self.right.previous is just this node. And then self.right.previous.next is also this node. However, this self.right.previous is already being updated here. So in that case, what we need to do is, let's say, let's do this line first. So basically, that is, okay, the original when we insert a node, so the node, the previous node of this newly inserted node is self.right.previous. And then for this node, for this node, this next node should also point to node. So when we initialize on line 27, we only point this node's previous to this self.right.previous. Let's say set this self.right.previous, set this node to be this node's previous node, but we did not set nodes to be the self.right.previous next node. So that's what we are doing in line 28. And then after we do this, we also need to set this node as self.right's previous node. So in that case, we call self.right.previous equals node. And then for the enqueue, that's kind of how we insert the elements. But what if it is already full? So in that case, if self.dot is full, if it's already full, we just return false without inserting the element. If it's not full, we just insert the elements in queue and then return true. So for the dequeue, so we check. Basically for dequeue, delete elements if true is operation is successful. In that case, we check if self.dot is empty. If it's already empty, then we cannot delete anything. So in that case, we just return false. So otherwise, let's delete the elements. So for delete elements, we delete the node after the left pointer. So basically self.left. So this self.left.next is the elements that we are going to delete. So in that case, so this is element to delete. This is element to dequeue. Then its previous element is self.left, and then its next is self.left.next.next. So in that case, we want to actually get previous. Next is just self.left, self.left.next.next. We want to previous.next is just next dot previous is just previous. And then we just return true. If it's front, so if self dot is empty, we just return -1. Otherwise, return self dot left dot next dot value. But in this case, we can actually set the, we do not have to check if it's empty because we have left and right pointer. So here we can actually rewrite this one. So in this case, let's self the left node value set to -1, self the right node value set to -1. So in that case, we can just return self dot left dot next value, and the rare is just return self dot right dot previous dot value. Because the default value for left and right are just -1. And then if to check if it's empty or is full. So in this case, we need to actually keep track of the count. So let's initialize self.count to count the number of elements. So once we enqueue, after we successfully insert, self-count is increments by 1. And then for the dequeue, self.count 1. And then to check if it's empty, return self.count is 0. Return self.count is just self.k. So this is our solution. Okay, this solution is accepted, so let me try to recap the idea for solving this one. So basically, the idea is to design a circular queue using the linked list, doubly linked list. So we have a linked list and we have a left pointer, right pointer to denote the start and end of this linked list. So in that case, dequeue is just delete nodes after the left pointer. Enqueue is just insert node before the right pointer. And then we specify the node for this linked list. And then we also have the left and the right pointer. And then we perform the enqueue and the dequeue. It's just to check if this node is empty, if this linked list is full or empty. So this is our solution.